Right, I'm getting the signal that I'm live now, so I'm going to give it a couple minutes and see how it goes. So, it is working. Right. So, I guess I'll just begin.
Right,
Anyway, my name's Tom Mitchell,
sort of
affiliated with Pisoc, sort of affiliated with Campus
see how
Devs.
it goes.
University
it's
of Bradford alumni, that sort of thing. I'm going to be talking to you today
Right.
about Git and GitHub,
So,
and how they're different, and how they should be used, and why you should be using them. I guess I'll just begin. Okay, feedback. Apologies. So, Git was created by Linus Torvalds, the creator of the Linux kernel, as a way to manage development on the Linux kernel. Sort of a preface of the history of it. Getting to what is Git, Git is a distributed version control system. What does that mean? It means it's a way for you to control changes to source code over a larger sort of system, multiple developers, that sort of thing. It works essentially by storing incremental snapshots of a given directory. We can consider that a project, or in Git terms, a repository. And you can have multiple sort of branches of this snapshot. If you consider the way a tree is structured, like a literal tree, it has branches coming off of it, right? Git allows you to have that same sort of structure. 1 second, apologies. So the difference between a given snapshot is often shortened to a diff, and that's a diff or a difference, and that's kind of what this next slide explains, where we consider this as a Git repository, essentially. These sort of check-ins here might be called commits, depending on exactly how you want to use the terminology. We can see version 1 here. We check in, files A, B, and C. That's a bit of your source code, something like that, a bit of a project you're working on. Now, version 2 updates file A and file C, but it doesn't update version B, so we don't actually check in a new version of version B, because we can say, well, between versions 1 and 2, nothing changed, so we don't need to record anything about it. We just say, look at the last one, that's fine. Version 3, for example, might not change version A, file A, it might not change file B, but it might change file C again. So we say we have to look at the difference between those two sort of check-ins and record that. Now finally, file B does get changed, and now is when we store the next check-in, the next diff for file B. And instead of referring to that sort of version of a file we saw in version 1, we now we refer to the file in version B. There's a number of tools you can use to sort of use Git, essentially. Git's separated into what's referred to as plumbing and porcelain. So there's the actual sort of nice shiny front end bit of it, and the bit that does the hard work at the back. And this has been implemented, or this front end bit has been implemented in various fashions. So there's the classic command line tool Git. There's also a variety of GUI-based tools, if you're that way inclined. So Git, Kraken, and Tower are two highly popular ones. Personally, I've never used the GUI ones. I would recommend going with a command line tool. It's pretty much industry standard, and you'll find a lot of useful advice out there if you're looking to learn it or have questions about it. So why use Git? To answer this question, I'm going to preface by explaining how you would do version control of source code without Git, and it's not exactly pretty. You could, and I've seen people do this, you could zip up your whole source code directory and put it on Google Drive, and anytime that someone wants to make a change, they pull the thing down and they make a change and they put it back on Google Drive. There's a number of pitfalls in this. In that, how do you sort of manage two people working on it at once, for example? How do you solve conflicts between different changes that different developers might do? How can you store previous versions, or how are you going to version those previous versions? Are you going to store maybe a timestamp .zip, and then you always look at the latest one? If you want to roll back, you look at the last timestamp. How would you look for a certain bit of code? Let's say that someone's made a change and they've introduced a bug. It happens, we'd like it not to happen, but that's the nature of software development. How are we going to pin down who introduced that change, and how we might go about like looking at why they made that change, or what we can do to address that specific bit of code. In a similar note, how do we know actually at all the insight, or get insight on the difference between two versions are? So, I might upload a new version of a zip folder or something like that, and how do I compare the code in the new version versus the code in the old version? In a similar fashion, you're sending code back and forth over as a zip file in email or in Facebook Messenger, or potentially on a ticket tracking system like Jira, Trello, or ClickUp. These all have roughly the same problems because they're really not geared to do source code management. They're designed to store static versions of files, or to send emails to people, or to track tickets rather than code. Bear with me a second. Having to look at my speaker's notes on one screen, actual slides on the other, so apologies for slight delay here. So the motivations for Git basically are that it solves all the previous problems we've discussed, including easily facilitating collaboration between multiple developers, potentially different offices, different continents. It manages all that basically seamlessly. It's hugely it's hugely adopted because of this. Subversion and Mercurial, which were tools that solved similar problems in the past, are basically ancient history at this point, because Git's beat them, by far. It will make your life easier if you're managing or trying to work on software projects with other people. And as a result of this, and the widespread adoption, it's basically a requirement to get a software development job. I think you would be very hard pressed to find a software development position if you weren't at least familiar with the basics of Git. If you went in blind, then I think you'd have a lot harder of a time trying to get the job. We're going to go into a demo a bit later because we're rolling the demo for both Git and GitHub into one. But you may have also heard the term GitHub, or heard of the website GitHub. And there's a lot of confusion, I think, especially with people who are new to this sort of thing, over what is GitHub, what is Git, are they the same, how are they different if they aren't, that sort of thing. Essentially, Git is the tool that allows you to handle this, actually making incremental changes to source code and merging between different branches of them and that sort of thing. But you also require a Git server to centralize all of those changes. This is, I think, typically called an origin in Git terminology. You can have multiple sort of remotes. Sorry, it's got a remote, apologies, it's the wrong term to use. You can have multiple remotes or multiple servers that you can push out these changes to in different places. GitHub essentially provides hosting for a Git server, or hosting for Git repositories. It is kind of a Git server in a sense, which is really nice because you don't have to set one up yourself, because that sounds like a right faff. So Git server hosting is one of the things that GitHub provides, and it's kind of one of the niceties about it. But it also brought on a whole sort of movement of what I guess could be described as social coding, in that it not only does the repository hosting for you, it also manages all the things that you might need over the sort of span of a software, or the life cycle of a piece of software, or something like that. So as I mentioned, yeah, I sort of brought in this idea of social media plus software development, that sort of thing. Their tagline is, well, the world builds software, and they're kind of one on that front in a sense. They are the premier of social coding. They also offer repo visualization. On top of these sort of social features is repo visualization, so you can look at a page on GitHub and see, well, this repository has this file, this file, this file, etc. Issue tracking, so a kind of lightweight ticket tracker for problems you might have with your repo. Let's say you've got a bug, someone else uses your bit of software, you can pop that bug up on the issue tracker, and the author can acknowledge that, and you can discuss and work on the issue. It manages pull requests, which is kind of a feature around Git's merging, which allows you to say, I've got this branch on this repository, I would like you to pull the changes that I've made here over the top of your branch, and that's a really nice feature for including things like new software features or like bug fixes in code. You know, you can separate out the work you do into a separate branch, and you can say this branch is just for solving this bug. And once we've made the changes into the code that solve that bug, we can then go and merge that over the top of what's generally referred to as the master branch, the main branch of a repo, and then we have a consolidated sort of nice chunk of commits to add to the master branch. Commits to this idea of a single change that we discussed earlier. GitHub also do sort of on the back of the pull request feature, you can also do code review as a part of that, so you can go and comment on changes to code. So if someone submitted a really bad patch, you can say, no, please improve the quality of your code and come back later. We might merge at that point. They also add some nice things like static site hosting. So this is what we call GitHub Pages, which allows you to, for your sort of GitHub profile or for your for a specific project, allows you to host a static website on GitHub's infrastructure. They also offer wikis for documentation and releases for snapshots of source code, as in like a released bit of software or a version, that sort of thing, and a whole lot more stuff on top of that. Really, it's really a very, very full-featured package if you want to dive into the world of software development, or software engineering rather. A nice thing on top of this is it also acts as essentially a public repository, a public portfolio of your software development work. So I'm sure people have heard before that companies like to see people who have got side projects because it shows skill in certain areas, it shows you're passionate about the subject, etc. You can put all your code on GitHub and you say, hey, look, company, look at this cool thing I wrote in my spare time. You should hire me. There are a few alternatives if you've got some sort of moral injunction against GitHub. Apologies. They're not the only people to embrace this sort of social coding idea. There's GitLab, which is a very popular alternative, and I think has been since Microsoft acquired GitHub. I know that wasn't popular with a lot of people. GitLab also offer their own, well, it's not quite as unique now because GitHub also do it too, but their own continuous integration and deployment solution, which was a nice selling point of GitLab for a while. There's Atlassian's offering Bitbucket, which integrates nicely with Jira. So if you use the Jira project management sort of tool thing, Bitbucket plays very nicely with that. A lot of good integration there. And there's SourceForge if you're from the past. I've never really used it. I don't know if people still use it. I don't know. So I've run out of slides here, so we're going to go to the demo. I think I'm a little bit ahead of schedule. Apparently I had less to say than I thought it is. So I've got a GitHub repository here. It's called Git Demo. As you can see, there's a lot of amazing nothing in it at the moment. But we've got an issue here. So it's been requested, apparently by me, that we need to add more text to the README file in this repository. So this is an example of a GitHub issue. As you can see, I opened it about a month ago. I've got a description of what goes on here. I can leave myself a comment if I want I want to say maybe discuss the issue at hand, that sort of thing. Let's have a look at this then. I forgot where I was going. Oh yeah, so GitHub has a nice feature where it will visualize files called README at the top level of the repository. I think GitHub has made quite a push for what they call GitHub flavored Markdown. Markdown being a way to sort of describe the way text is structured. So for example, this, you can see here actually this is the actual text contents of the file, but it's nicely sort of rendered for us by GitHub as such. So cloning a Git repository. On GitHub, Git has a concept of cloning a repository, which is to take a copy of the repository from the remote and put it on your local machine, which obviously if you'd like to do some software development sounds pretty useful. So you can clone over HTTPS or SSH, just different modes of transporting the files to yourself. And let's see, that does work, cool. So in this case, git clone, and type an SSH key password in, and that's clone the repository. It's really just as simple as that. Git clone, and then the remote sort of the way you are addressing your remotes. It's going to be one of these two here, basically. Or you can use the GitHub CLI, but I don't know how to use that, so I'm not explaining it. I've not tried it out. So we look back at this terminal here. So we now have our Git demo repository. So you can see we've got the files that we saw in GitHub. That's that README, is that README. It's about as simple as that. So let's say we want to address an issue of our source code. So I here think that we need more text added to the README. Given the tiny amount of content to it, I'm kind of inclined to agree. So this is something I've actually not used too much on GitHub, but we can add a label potentially to say what sort of request this is. Is it a bug? Do we want better documentation? Is this a feature request? Is this issue good for newcomers to be open source for? So let's say someone's found your project and they would like to contribute, but they're not having a vast amount of experience with it. Maybe it would be good if they could look at some simple issues first and get their bearings. Okay, there's apparently no way to mark this as in progress, which okay, there might be, but I'm not. For work, we use GitLab, so I'm not as familiar with GitHub's sort of UI in this sense. But if you look around yourself, you may well find what I'm looking on, what I'm missing rather. So let's make some changes to this README. So some really cool text. What I am just now. Some fantastic additions. Add some really great content, really great new features to the code. Really, we're just making an arbitrary change to demonstrate the further features of Git here. So we made a change. Great. What do we do now? Well, we run git status. We can see that essentially the status of the repository. And in this case, our branch is up to date with origin master, which we'd expect. We've not added any new commits to the local copy of our branch, but we've got some changes to files which we haven't staged for commits. Basically, the way Git sort of manages that staging thing is you have changes, and those changes are added to the staging area, and the staging area, when you run the commit command, is all added to a commit. So in this case, we've got files that aren't staged but are changed. So, for example, we can run git diff to see the difference here. We can see that this diff has come out and that we've added this line of text here. Run that git status again. Now we can check out a file which will just how to best describe this? Essentially, to do a git checkout is to pull out a specific sort of commit or changes or the files at a specific commit in a sense. So we could check out, for example, I believe that dash there means head, so it's like the sort of top of a repository in a sense. With readme, which would essentially mean we're discarding our changes, but we don't want to do that in this case. And I think when you're just beginning to use Git, you probably won't need to do that immediately. However, it's very well documented if you do need to do that. There's some resources linked at the end of the series of slides that will explain this sort of thing in slightly more detail. What we are going to do is git add readme. So now that's added the changed file to the staging area. As you can see, we've got this file's now gone green rather than going red. It was here, it's now green, which means it's in the staging area. Let's say we added a file by mistake, we can just git reset readme. And you can see unstaged after reset, and if we run git status, we're back to where we were before. So I'm just going to re-add readme. So back in the staging area. Now let's make a commit. So this is the basic sort of syntax for basic command for making a commit into a Git database. I think that's the correct term to use here. So git commit -m, which means message, because typically when you're making changes, you will want to explain those changes, and having a message, is a nice way, just a little bit of text that explains what you've done there. So in this case, add some really cool text. As you can see, we've made a commit on the master branch, one file change with 2 insertions, which are the 2 lines we made. Git status, we can say our branch is one ahead of origin master, our branch is 1 commit ahead of origin master. We can push these changes push the local changes to the remote with git push. We're going to do git push. It's going to ask me for SSH key password again, and we have pushed our local changes to the remote. So now if we go back onto to click the thing, go back onto GitHub, and go back to Git demo, we can see that text we've just added is now there. We can mark in response. We could mark. You can show off one of the cool features of GitHub here. If we click on this text here, we can actually see the commits that made these changes. We can see the commits. So every commit is identified specifically by a SHA-1 hash. We can see this SHA-1 hash here. I copy that, go over to issues, add some more text to README. If we preview that, it will allow us to reference that commit in the message in a nice sort of reader-friendly format, right? Because that giant string there is a little bit unwieldy, but that one's quite nice, and it's hyperlinked for us, which is lovely. So close with comments, and we've resolved the issue. How useful is that? Now, if we wanted to do something slightly more advanced, we could look into Git branches. So branches on GitHub are displayed with this thing here, right? We only have 1 branch at the moment, because this is a very basic repository, but we're going to create another one in a moment. So let's create another issue. So yeah, do major development. Let's say this major development is to add a... Apologies, one of my speakers has become possessed and making very strange noises. So we add a new feature to the repository. What am I saying? Add a new feature to the project. Apologies. The speaker's sort of distracting. I don't know what's wrong with it. So let's submit a new issue. Now we've got this new GitHub issue here. As you can see, it's automatically labeled number 2. That's just a number that increments up as you add new issues. So you see a really popular project, or a really buggy project that's got a very, very massive issue sort of increment. So we'll go back over to the terminal here. So let's say we've seen this issue. We've got the latest version of the repository, and we can check we've got that by git pull. And I'll type password in here. We're already up to date, which means there's no changes on the remote that isn't on our local repository. So let's make a branch for our new cool feature. So we'll git checkout -b feature add foobar. Adding foobar is a really great feature. So we're now on a different branch. We can consider this like a different slice of history essentially, or a different stream of commits on which we're working. If we run git branch here, we can see that well, we've now got 2 branches. We've got master and we've got feature add foobar. We can run git log, which just kind of shows the history of a repository in your command line. We're looking at here. So the commit we're currently looking at is feature add foobar, is the head of this branch, as well as the head of origin master, as well as origin head, and of the master branch. So okay, check out the master branch. We can look at that again. We can see, so head is now master because we're looking at the head of the master. The current commit we're looking at is where master is. Origin master is this commit as well, as is feature add foobar. Oh, that's the wrong branch. Add foobar. So we're now back on our add foobar branch. That's what this checkout thing is for. It's checking out a specific commit or checking out a branch, etc. Checking out tags as well, which we're not going to cover, but is a very useful feature of Git. So let's say we want to add a cool feature. So let's add some Python, because it's a good programming language. Let's write app.py. So print hello world. Amazing new software as a service. Will make billions of dollars, I'm sure. If we run Python app hello world, well, you can see hello world. We'll consider that in this case a major new feature. So we run our git status command again. We can see we're on branch add foobar or feature add foobar, and we've got these untracked files. It's just the same as last time. We'll add app.py. We'll add our files generally. We'll write a commit message for the change we've made. And we are on branch feature add foobar, and we've got nothing else to commit because we've committed everything. Now, if we run git push, we're going to run into some problems here because Git, or at least the setup or the sort of configuration on this machine doesn't actually know where to push this branch. It knew where to push master because we cloned it and it was set up kind of as it did that, but we don't know where to put the feature add foobar branch. Now you can, so you can run the set upstream thing to set it permanently. So you would run git push origin add foobar. This says where, which is in this case is GitHub. If we look in git config, oh, that's not what we're doing. There we go. So we can see this origin here is that URL we put in earlier, which specifies, it's github.com, it's this user, and it's this repository. We just run git push again to get that message back. So we're saying, GitHub on this branch, please. And this will set up this sort of relationship permanently, so we don't have to set up again in the future. So I'm just going to, instead of doing it manually, we're just going to copy paste that in. Put in key password again, and we have, slightly slow today, we have pushed our new branch up to GitHub. So we hop back to GitHub here, go to our code section. As you can see, it tells us that we've pushed a new branch, and here we can see our lovely new branch, which has got this commit that we've just added. So we look at, that's commit starts OIF. And if we run, oh, you won't be able to see that, apologies. If we run git log here, we can see this top of this sort of chain of commits essentially also starts OIF, it's the same commit. SHA-1 hashes are avalanching in a sense in that you will, even if the content changes very minorly, you'll have a massively different commit hash. So you can be fairly certain, unless you're really bloody trying to, but you aren't going to have two of these hashes overlap. In fact, I believe there's only ever been one instance of that happening, which was a team at Google intentionally trying to make two files which would collide, and it took them a really quite a long time to do it. So if we look back to GitHub, so as GitHub's kind of usefully doing, it's suggesting we open a pull request for our new branch. As explained earlier, a pull request is basically saying, I'd like you to take the contents of this branch and glue it on top of this branch, such that the head of this branch, or the sort of, let's call it the like to branch, becomes the head of the source branch. And we'll show kind of exactly how that works in a second. So click compare and make a pull request. We're able to merge because Git's quite nice at looking at two branches and determining if merging them will cause what's called merge conflicts, which are, sometimes a nightmare to resolve, sometimes very easy to resolve. More specifically in Git, merging used to be, in some version of Mercurial, something you try to avoid, whereas Git made it a sort of first-class citizen in a sense. It's much nicer to do this with Git than it is with other tools. So let's say our pull request here, like I want to, this pull request adds a cool new feature. As it says on the tin, please add foobar to the project. Now you can imagine that this is, let's say, is your favorite Python library or whatever, and you want to add a new feature to it because it's something you kind of want, but no one else wants to do the development, so you added it yourself. Imagine you're opening a pull request to add that feature. And when it loads, there we go. So we've now got a open pull request for this cool new feature. That's the description we set, title we set, etc. Apparently my browser is peeking out from the thing. Apologies. You can see my bookmarks and all the really boring stuff I read. GitHub has, as I mentioned, now has a kind of nice inbuilt continuous integration solution. CI and CD are somewhat outside the scope of this talk, but they might be discussed by other Pisoc talks in the future. Consult your local Pisoc exec. You can do, I won't go into it in this case. So as Git said, there's no conflicts with, I guess, what they call the base branch in this case, which would be the master branch, because we're merging our feature branch into the master branch. Nothing's going to conflict here, so we can go ahead and merge the pull request, and we can give it a nice message and stuff like that. So in this case, merge pull request free, which is this one, from this branch with this message, confirm merge. I'll let that wait for a second. So now that the merge request has gone through, GitHub updates this sort of timeline of what's been going on with this. Closes the pull request now that it's been fulfilled. Basically, there's nothing else really to be said here. Of course, we can comment and reopen it and that sort of thing if need be, but I'm pretty sure this feature's bug-free, so let's not look into that for now. But if we go back to code, we can see that on the master branch now, we've had app.py merged in, which is great. Our feature is now in the sort of production master, serious branch. But what we have done now is introduced a commit on the remote that's not on our local repository. So, obviously this might cause problems. Let's say you're developing a feature and things get merged in upstream, then you're making changes, like essentially changes to things that have happened in the past. You're going to want to synchronize your changes with the remote, and typically if you've got a lot of people working on one repository, it's probably, definitely is very good practice to git pull frequently when changes have gone out, that sort of thing, to make sure that you're not going to have conflicts. You can also avoid these conflicts by using sort of proper branching. There's multiple sort of what you would describe as kind of emergent behaviors that have come out of various Git workflows. I know lots of companies have different opinions on how you should use branching or how you should name your branches, that sort of thing. And once you're with a team of developers or you're at a company, that's either something they'll have established or something you'll need to establish yourselves. So if we go back to Git now, we can see we're on branch, we're on the branch where we left off at. Let's check out master, because that's where all the new hotness is. Now, our local branch thinks that we're up to date with origin master, but this is not the case. So let's git pull, and again, enter SSH key password. There we go. So it's got one new commit, pulling these down, from master branch here onto origin master. On the master branch, pulling from origin master. Was able to fast forward these sort of changes because there was nothing to conflict or whatever like that. And as you can see, we've now got created this file app.py. So we've got ls. Haha, we've got the newest changes on our machine. And I think that's all the things I wanted to run through for this demo, because that's basically the sort of full basic usage of Git that will get you by for certainly student projects, unless you're doing something particularly complicated, in which case let the Pisoc exec know. I'm sure they'd be interested. This will probably be enough to to say with confidence, if you can do this and demonstrate doing this, that a company would sort of take you on with Git knowledge. You probably don't need further training unless it's in something very specific, and there are more things to Git that if you need to know them, you can look into them. But for now, that should be everything. So I guess I'll end the presentation almost with an XKCD comic, which you can't see because I've not clicked. There we go. XKCD, webcomic every node should know about, so I figure I'll just leave that on the screen for a little bit. And I don't have a question slide, so I guess that'll have to function as that. I'm being told source tree is also good by a gentleman in the chat. Hello. I have not used source tree. Maybe check it out. I don't know about it. So, has anyone got any questions? And now I'm going to have to wait a little bit of time after I've said that to see if the questions come through. So. Shoot a message off to Pisoc exec so we can coordinate. Doesn't look like any questions are coming through, so it makes my life a lot easier. Nothing has come through, so yeah, I think I'll call it there if no one's got anything to ask. Thank you very much for watching.